And we're on to day 3 of Advent of Code 2024. If you're new to the channel, you've missed a lot. Advent of Code is a series of programming challenges, and I am attempting these challenges in Funciton, an esoteric programming language that I invented. If you want to know more about Funciton, there is a link to a video series in the description. Now, I've personally had a lot of fun with the previous 4 challenges, the 2 challenges on each of the first 2 days, so let's see what the third day has in store for us. Shall we? Day 3. Mull it over. It seems like the goal of the program is just to multiply some numbers. It does that with instructions like mull xy, where x and y are each 1 to 3 digit numbers. For instance, mull 4446 multiplies 44 by 46 to get a result of 2024. Very appropriate. Similarly, mull 1, 2, 3, 4 would multiply. Okay. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mull instruction. Sequences like mull of 4 asterisk. Ooh. Okay, they should just do nothing. Okay, so it's not like we're trying to figure out what's going on here. No, we just ignore the whole thing. For example, consider the following section of corrupted memory. Okay, so I'm guessing that it's highlighting the ones that we do need to care about. Only the 4 highlighted sections are real instructions. Okay. Adding up the result of each instruction produces 161. Scan the corrupted memory for uncorrupted mull instructions. What do you get if you add up all of the results of the multiplications? Now, if we were doing this in a normal programming language, the obvious first thought is regular expressions. But Funciton, being an esoteric programming language, doesn't have regular expressions, at least not built in. Now, I'll be level with you, I've actually had a lot of thoughts about implementing something like regular expressions in Funciton, and this would certainly be the perfect use case for it. But I set myself the challenge to do these Advent of Code problems right here, right now, so I think I'm going to do this the manual way, and then think about implementing more generic regular expressions sometime later. But until then, let's do it manually. Now, this is the example input that was given by the website. I've added a new line like halfway through so that it fits on the screen, but the output should still be the same, right? Because it would ignore new lines and white space. Let's start by worrying about how to detect if such a mull operation is at the start of a string. So a string like this, which starts with an X, would just be completely rejected. And so would this, because it doesn't have the close parenthesis that it needs. So if I had a string like this, for example, it would capture the MUL and then the parenthesis. It will find the 5,5 and check for the close parenthesis, and then it would stop and ignore the rest of the string, which in this case would be the plus. And if the string doesn't start with a multiplication thing, then let's just return 0. So I think the first thing I need to check for is whether the string starts with MUL open parentheses. Now, you may remember from a previous video that I wrote a helper program which I can pass any string in, and it would give me the integer representation of that string. And now I can use that integer in the program to represent that string, MUL open parentheses. Now, the first thing that the program needs to do is to check if a string starts with this. Now, remember that strings are represented in Funciton with 21 bits per character. So we're actually looking at the first 4 characters, so 4 times 21, that would be 84 bits. And in order to extract the first 84 bits of a number, we need to bitwise AND with a number that is essentially 84 separate 1 bits, which is the same as 1 shift left 84 minus 1, which happens to be this large number here. Oh boy. So let's draw a little frame around this number as well. And now let's formulate our first if condition. So we need to check if the string starts with, mull open parentheses, which is represented by this number. And if it does, well, then we're going to continue processing. And if it doesn't, then we said we're going to return 0. Now, to check if it starts with that, we need to bitwise AND it with the bigger number, which I'm going to call M the mask. And we need to check if that's equal to the other number, which I'm just going to call N. You know what I mean. So to check if they're equal, let's put an equal box here. I'm going to put the constant, which is the N, on the bottom, which will allow me to put the rest of the logic up here. And the rest of the logic is S with a bitwise AND. Now, you know that Funciton can only do bitwise NAND, but we can do a bitwise AND in terms of NAND by just doing a bitwise NOT after the NAND operation. So we need to put the NAND operation here on top, and we don't need this number anymore, and it is now this number that we need to bitwise AND this with. So to proceed, I need to figure out how many digit characters there are after the open parenthesis. So I'm going to have to write a helper function for that because it's going to need to be a recursive function. So let's grab an example string here and let's scroll down a bit and put that string here. So we want a function which, if I pass it this, it should return the number 2 because that's the number of characters at the start of the string that are digits. And if it doesn't start with a digit, then it would return 0. Now, I was tempted to say the first thing we need to do is check if the string is empty, but actually we don't. Let's think about how we would extract the first digit. Well, the first character is going to be 21 bits, so we want to look at the bottom 21 bits, and then we want to shift them out. What happens if you look at the bottom 21 bits of an empty string? The answer is you get 0, which is not going to be in the range of the Unicode values for the digit characters. So let's actually start writing a question mark box for the condition of whether the string starts with a digit or not. Now, in the code that we wrote earlier, we have a condition kind of similar to this. So actually, I'm just going to copy this code here. But now instead of this humongous number, which corresponds to 4 characters, we want only 1 character. So we need to calculate 1 shift left 21, which happens to be this number. And now instead of checking if that is equal to something, we actually want to check if it's in a range. Now you may recall from previous video that I have a range operator thing here. So I'm going to use that again. And the order of arguments for this one is lower bound first. So this needs to be the lower bound. So the lower bound is the Unicode value for 0, which happens to be 48. So let's put 48 here. And then the next argument is the value that we need to compare. So this stuff needs to go in here. And then the upper bound needs to be the Unicode value for the digit 9, which is of course 9 more than that. So it would be 57. But now let's remember that this function is actually exclusive on both bounds. So I need the value to actually be greater than 47 and less than 58. So if the first character in the string is in this range, then we will continue processing. Otherwise, we want to return 0 to indicate that there are no more characters that are digits. So what if there is a digit? Well, we need to do a recursive call to find out how many more digits there are in the rest of the string, and then of course it's 1 more. So we need to add 1. So I'm going to put the increment function here. And then we need a recursive call, and conveniently this function is going to be 1 parameter, 1 output, and I'm going to call it 3 in a circle. And then what goes in there, let me scroll up a bit. I completely forgot that we had the example string there. So what needs to go in here is the string, but with the first character removed. So we need to shift the string right by 21 bits. And in order to shift it right, I'm going to shift it left by a negative amount. So we want negative 21 here. All right, now let's join up the S's and draw a declaration box. Now I want to test this function to make sure that I haven't made a mistake. So I have to quickly write a test program for this. And my test program is just going to take standard input, which is already a string. And then we run it through the function that we just wrote. And then we turn the result of that, which is an integer, into a string so that we can read it on the console. And then I need to temporarily remove all of the other stuff in this program file because otherwise Funciton is going to complain. Now I'm just going to put this here to the side so that you can see this. And then let's run this, and let's run it on an empty string, which should give us 0. Let's run it on a string with digits in it, and that should give us a 6, but it gives us a 0. So what's wrong here? Did you spot my mistake? It's probably hard to notice because I didn't show you how I arrived at this number here. It turns out I calculated it wrong. What I did is I went 1 shift left 21, and I forgot to subtract the 1. So if we subtract 1 from this number and change that to a 1, and then we run the same program again, we now get the 6 that we expected. And if I add even more digits, we do get that. And if I put a non-digit character somewhere inside here, I should now get a 4, and I do get a 4. So that first function we wrote is working. So let's scroll back up to the program. So where were we? We've checked if the input starts with mul open parenthesis. So the next thing we need to do is check how many digits there are. And if there are no digits, in other words, if that gives us 0, then we need to stop because then it's invalid syntax. So we're going to add another question mark here, but as you can see, space is getting a little tight. So I'm going to move this over to the right. So the next condition that we want to check is if the result of our function is equal to 0. Well, rather not equal to 0. And of course the question mark function already does that check for us. So it's literally just that. Which reminds me that this other condition that we have here is an equals, which means that we can use the optimized interrobang function here. Okay, so if the result from the 3 in the circle is 0, then we want to return 0 as our result, because it's not valid syntax. Else, now we need to check that the next character is a comma. Again, the example doesn't seem to contain anything where you have mul and then a digit and then something other than a comma. But checking for a comma is easy enough. It's essentially the same thing that we have here. So let me just scroll to the right and let me just copy this whole thing. And let's try and finagle that into here somehow. Okay, one further up. So this 3 needs to go here. So we need to check if it's a comma. So this needs to be the Unicode value for the comma, which is 44, as you may or may not remember from previous videos. And of course we're checking only one character, so this needs to be the same value as we had in our other function, which is 1 shift left 21 minus 1. But now we need to be careful because the string that we're trying to look at is not actually S. It's not the original string. We need to remove this amount of characters and then check the next bit. So this is actually S shift right. Let's see, we want to shift right by. Well, this tells us how many characters of, how many digits there are, and then we need to add 4, so it's that plus 4, but that's the number of characters, so we need to actually shift right by 21 times that much. Okay, but now I feel I'm kind of getting ahead of myself, because I just realized that what do we pass into this 3 function? That also needs to be only a part of the string, not the original S, because we need to remove the mul thing. So I'm going to remove this plus 4 here, and then we don't need these parentheses anymore, because this one actually needs S shift right 4, and then we can reuse that string when we calculate that string. So let's unconfuse ourselves. So we want to call this function on this string, which in fact we're shifting right by 4 times 21. I should probably write this properly, so that would be 42. But we need to remember that this S here is not actually the original S, it's actually S shift right 42. So I'm going to call that T, and I'm reminding myself that that is T. So let's put this here. So we need the result from the 3 in the circle in 2 places, and one of those places, which is here, literally just takes the result of that, whereas the other one is up here. So I think we're going to need a y-crossing function to punch through here and just connect this up. Now let's write this shift right part. So I'm going to move everything way off to the right again, and this needs to be the result of the shift right. So let's put a shift right box here. And the first argument needs to be the t, which is the same as this t here, so we're going to combine those in a second. And then the other one is the result of a multiplication, so we need a multiply box here. And of course there's not enough space for it, so I'm going to move things around. Now one side of the multiplication is literally the number 21, so I think we can fit that in here. And the other side is the result of this whole thing. So we need the 3 in a circle here. But if I put the 3 in a circle here, then it's going to move horizontally to the left and it'll crash into this. So I think it's more useful if I angle this up and then have the 3 sort of go vertically up. And the thing we're passing into that 3 is of course this bit, which we called t. So that is literally t, and we will be able to combine these. But first of all, the result of that 3 in a circle also needs to go into here. And then let's connect these up. But now I don't want to lose sight of what t is, so I'm going to write the formula for it here, which is S shift right 42, which I suppose we can also write right here. Actually, it's 84, because we're removing 4 characters, the MUL open parentheses. Okay, so input string goes here, we chop off the MUL open parenthesis, and then we count how many digit characters there are after that. And if that is 0, then we just return 0. But if it's not 0, then we take our string, which is now this part, and we shift it right further by 21 times this, which is the number of digits. So we're left with the string that starts with commas. And then we're checking if the last character of that, the first character of that, is equal to the comma. And if it isn't, well then we want to return 0 again. So why don't I move that 0 around a bit? And of course, since this is an equals function, we can use the interrobang again. Okay, so now we've checked everything up to the comma, which means that we now need to remove one more character, which is the comma, to get to the next part with digits. Oof, so let's see. So this is the string that starts with the comma, and we're checking if it starts with a comma, which means that we now need to branch off of this and then shift right it by 21 in order to remove the comma. So this is the string, and we want to shift it by 21. That means the output here is pointing the wrong direction. We need the order of operations like this. And then this is where the new string comes out. So this is where we get this string, the one that starts with a digit again. And once again, we're going to need to split it just like we did here. We're going to need two versions of this, one of which we pass into the circle3 function in order to count how many digits there are. And the other one, we need to shift right that many bits in order to get to the close parentheses. So let's make some more space up here. Now, it seems that the code is going to be growing upwards. So I'm just quickly going to worry about where this S needs to go, because it needs to join up with this S down here. So I think I'm going to move this up a little bit here so that I can put a wire crossing function in here. We may or may not want to put that S here later. So let's see, we now have a string which starts with the next digit. Okay, so what we end up putting here is basically the same thing as this, but it's gonna come out upside down. But just as down here, we're going to need the result of the 3 in the circle in order to put another condition, because the next condition after this one is going to be that there was, in fact, at least one digit. So I'm going to put this question mark box here right now, and then I'm going to worry about how to connect these up. So the result of this thing up here, so this value that comes out the right, needs to go into here, and I think we can get it there by punching through this wire. I'm going to move this S to the other side as I prognosticated that I would, so that I can move everything over to make space in this little corridor here. Okay, so that's the next condition here. So we need to return another 0 here if that condition fails. And then we're going to have another condition later to check for the close parenthesis. So I'm going to make another 0 box instead of trying to reuse this one again. So now what comes out of here is the string that potentially starts with a close parenthesis. So now we need to use something like this, the bitwise AND with the number that represents 21 bits, to check for the close parenthesis. Now I'm debating whether I need a copy of it, because I need a copy of it here in order to continue with the next calculations. But in this case, we only need to check for the close parenthesis. We don't actually need to remove it. So I don't think I need a splitter here. So let's just put this number somewhere over here. And of course we want a bitwise AND instead of NAND. So I'm going to copy the not box and put it inside of here. And then what comes out of here is the single character that follows all of these digits. So we need to use an equals like we did here to check if that is a close parenthesis. And then we need to compare against the Unicode value of the close parenthesis, which happens to be 41. Okay, I am now going to zoom out a bit in order to be able to see more of the program at once. And now let's put the question mark here. Now again, we are comparing using an equal, so we can use the optimized interrobang function. And now we need the result of that equal to go in here. So if the character is equal to 41, then it is a closed parenthesis, so we're golden. So this is the final yes branch. This is the happy path where we are actually going to multiply two numbers. We haven't extracted those numbers from the strings yet. So we need to fiddle all the values that we need out of this salad of boxes. So let's see, the string goes in here, and all that happens down here is just checking its first 4 characters. So we don't care about that. We care about this part where the S goes. So this is where we remove the mul, and then this is where we find out how many characters we need in order to extract the first number. So I think I want to take a copy of the number that comes out of here. So this is the length of the first number. Let's call that L1. And we know that the substring always starts at index 4. Now let's see where the other number is. The other number comes out of this function, and since this one is upside down, it goes up to the top. So we can actually just branch it out of here, and I'm going to call that L2. Now surprisingly, I can get L1 out of this box by only going through one wire here. So let's see if I can do that. Okay, now we've liberated L1 and L2. So in order to extract the first number, I need a substring. And I'm planning to use this function here, the substring function that's already in the library. So the order in which the arguments go into the substring function is string, and then index, and then length. And I've already piped L1 in here, which is the length. So before the length, we want the start index, and the start index is always going to be 4, because MUL is always 4 characters. And that means that the string needs to go in here, and that's the original string, so it's the same as this string. And then what comes out of here at the bottom is going to be the substring, which we need to turn into an integer. And then we need to do something similar for L2, except that I now realize that in order to calculate the start index for the second substring, I actually need L1. Because the start index of this is going to be the 4 characters that are mul open parentheses, plus L1, the length of the first number, plus 1, which is a comma. So it's L1 plus 5. So we've got our copy of L1, now we need to add 5 to it. Okay, let's add some more new lines here to make some more space. I want another substring. So in counterclockwise order, we want the string, and then the start index, and then the length. So if this were to be the start index, which I'm just going to call ix, then the length would have to go in here, which is L2. Which means that in order to make this work, I need one more wire crossing function. Now that we have the index and the length, the first thing for the substring function is the string. So that needs to be s. And then this is where the substring comes out, which means that we need to convert that to an integer as well. And then finally, we need to multiply those two, this one and this one. Now I'm going to put that multiplication up here. So I'm going to rejiggle this a little bit. And then finally, the result of the multiplication that comes out of here needs to go into the final branch of our stack of question marks. Now let me zoom out to see more of the function. And I can see that there are 1, 2, 3 places for an s. And one of them is a little trapped, so we're going to need another wire crossing function to liberate that. And then we can connect up all of the s's. And then right at the top, let's add the declaration box. Now what should I call the function? We've already used the 3 in a circle, so let's use 3 in a double circle. This is the second function we wrote for this challenge. And now we need to get rid of this text here because the Funciton interpreter is not going to like that. Let's also remove some empty space here. And now we need to test this function. So I need to write a program. I actually have a program here, don't I? I can literally just change this to just that. So if I'm not mistaken, then that will run the standard input through the string that we give it, and it'll look for mul open parenthesis, number comma number close parenthesis at the start of the string, and then return the multiplication, the product. And then it will use this to output that as a string. So let's see if that works. First of all, let me cautiously run this on an empty string. It should return 0, and it does, although it took quite a long while. Okay, so let's see what happens if I type mul open parenthesis, and then let's try 1, 1. Let's see what that... Okay, that gives us a 1. What about 10, 10? That should give us 100. That seems to work. And of course, we can try the example in the puzzle specification, and that is 44 times 46, and it's 2024. That seems to be working. Now, if I'm missing, like, let's say the close parenthesis, I get 0. If I have extra stuff at the end, I should still get 2024, so that seems to be working. And if I have a close parenthesis but no number in between, I should be getting 0. And of course, if I have an actual 0 there, that also gives me 0. It just occurred to me that if we had interpreted a missing number as a 0, we would still just get 0. It would be the same thing. So we didn't actually need to check for the presence of digits. Alright, I wasted some time. Who cares? Okay, so far so good. Now we need to be able to find all occurrences of the mul syntax within a longer string. And here's how I think I'm going to do it. So for simplicity, let's say our input string is just this. What I'm going to do is I'm going to create a lazy sequence of all versions of that string with various numbers of characters missing from the start, all the way up to the empty string. And of course, all the ones that don't start with mul, they will just be rejected immediately. And the ones where the mul syntax is at the start, it will correctly parse it and ignore all the rest of it, even if it contains more muls. And it'll get to those other muls later when more of these string suffixes are generated. So I want to create a function that does this to strings, and since that function is pretty generic and pretty helpful, I'm going to put that in the library. Now this time we are creating a function that wants to check if the input is empty, although it's a string, not a sequence, but doesn't matter. And then as soon as we know that the string is not empty, we want to return a lazy sequence, which is a lambda expression. So we need to put a lambda expression box here. So if this is the lambda expression, then this is the input, and we don't care about the input, so we're going to silence that. The first output is the head, which would be the string itself, right? We want to start with the whole string. and only then we want to start removing characters. So the tail is going to be a recursive call to this function, but what we need to feed into that recursive call is the string with the first character removed. Let's start by putting the recursive call. And now I need to decide what to call this function, and I think I've already settled on a name. Because there's this cool Unicode character called an asterism, which looks like 3 asterisks in a triangle. I like that. So what we feed into that is the string, but with the first character removed, which is the same as shift right 21. And now we can just join up all the occurrences of str and just add a declaration box. Now let's put that function into the library. There's some space here to the right of the string to integer function, so I'm going to paste the function somewhere like here, and then let's write a comment for it. Now let's quickly check that this function actually works. So I'm going to remove the program that we had earlier to test our 3 in a circle function, and I'm going to write a new one. So we want to take standard input, and then we want to call the function that we just wrote. And now we have a sequence of all the suffixes of the string. So in order to make that fit for output, we need to join that with a separator. And I've just decided to use 44, which is the comma. Okay, so let's try that. Now if I run this with, let's say, ABC, I should be seeing ABC, comma, BC, comma, C. And I wasn't sure for a moment if it has an extra comma because I wasn't sure if I'm also returning the empty string. And it turns out that I'm not, but now I'm wondering if maybe I should, because the empty string is technically a suffix of the string, isn't it? I think for a library function, I probably should be pedantic about it. So in order to change the function, instead of returning a 0, I need to return a lambda expression, which has 0 as both of its output, one because it's the empty string and the other one because the tail is an empty sequence. So now I need to transfer this function into the library again, and it won't fit into this space anymore, so I think I'm just going to move it all the way to the right here, and the comment should go right above it. There we go. That looks nice. So now if we run the same, we should get an extra comma, and it turns out that we do. So coming back to our program, let me zoom out a bit. So we're taking our input string and we're generating all of the suffixes, and then we want to run every suffix through that big function up here that we wrote, the one with the double circle 3. So in order to run every element into it, we need a map function. So let's use the map function here, and then we need to pass a lambda expression into the map function. So this is the lambda, then this is the input, which is one of the strings. And this is the output, where we want the result to go, and this is the second output, which the map function doesn't care about. So let's put the 3 in a double circle down here, and what needs to go into it is the input that comes into the lambda expression right here. So now we have a sequence of all the results of that function, which is either 0 in the cases where strings don't start with mul or don't have the syntax, and it's the result of the multiplication in cases where they do. So now all we need to do is just add up all of those multiplications. And then the result of that is going to be an integer, so we want to turn that into a string. And that should be our program. So now if I run the program on ABC, I should just get a 0. But if I run it on anything with mul, so let's say multiply 2 by 4, we should now get an 8. And if I put an extra nonsense in front and after, we should still get 8. Very good. So now let's pass in the string that was given by the puzzle, which is this one here, and see what that gives us. That gives us 161. And indeed, 161 is the correct result. So finally, let's run the program on the full puzzle input. And this is probably going to take a very long time, and I'll let you know when it finishes. Turns out it didn't take that long, it took only 7 seconds, but I don't know if the answer is correct yet. Let's paste it here in the text box on the puzzle page. And it says that's the right answer. Very good. So we are 1 gold star closer to finding the chief historian, and we have solved 5 challenges. Now let me try and make a guess as to what the sequel to this one might be. Now the example input has a mul with square brackets in it, and also one here where the opening thing is a parenthesis and the closing is a square bracket. I have a suspicion that we're supposed to support square brackets as well, but not mixes. That is my guess, but I don't know because I haven't seen it yet. I will look at it in the next video.